Now this is question number 20 from problem set 3. It is in the form of fill in the blanks. Okay, so what is given? Segment AB is diameter of a circle with center O. The bisector of angle ACB intersects the circle at point D. Then prove that segment AD is congruent to segment BD. Okay, now see, draw segment OD. This is given in the proof. So draw this segment OD. Now angle ACB is angle inscribed in a semicircle, so its measure is 90 degrees, and as this CD is bisector of angle ACB, these two angles are congruent and they are half of the angle ACB. So angle DCB is half of angle ACB, which is equal to 45 degrees. And then we know measure of inscribed angle is half the measure of its arc, and that means measure of this arc DB is double the measure of this angle, so it is double the angle DCB. So 2 into 45, which is equal to 90 degrees. Okay, so measure of arc DB is equal to 90 degree, and therefore measure of the central angle is also 90 degrees. So this angle is 90 degree. Now as per the definition of measure of an arc, measure of an arc is same as the measure of its central angle. Okay, and OA is equal to OB because radii of the same circle. And therefore line OD is perpendicular bisector. This is perpendicular, and as OA is equal to OB, it is bisector. So in this box write perpendicular bisector of segment AB, and as OD is perpendicular bisector of AB, we know the perpendicular bisector theorem that each and every point on the perpendicular bisector is equidistant from the endpoints of the given segment. So D is a point on the perpendicular bisector, and hence it is equidistant from A and B. From A and B, and therefore segment AD is congruent to segment BD.